Hello and welcome everyone to LFI Educates. Today we are going to discuss about the equations of motion. Equations of motion for the motion of bodies under the effect of gravity, under the effect of gravity. Your equations of motion, as you know, your position time, velocity time relation, first of all, V is equal to U plus AT. If a body is falling under the effect of gravity, then this equation will become V is equal to U plus this acceleration will become acceleration due to gravity plus or minus gt. It will look like this. In this case, plus g we'll consider the coordinate axis. In our coordinate axis, we know that this is y positive and this is y negative. Y dash we write, this side is negative. If you go up, we'll take positive, and if you come down, we'll take negative, the value of g. And the value of g, we know that it is approximately constant, 9.8 meter per second square we take, or sometimes it's nearly equal to 10 meter per second square. Now the second equation of motion, that is your position time relation. The displacement or position s is equal to ut plus half of at square will get modified as displacement as we take along y axis. We can write y also, or you can write simply as height h is equal to ut plus half of plus or minus gt. Here also the value of g above. This one will take it as the ground level. This is your ground. Above will take positive, the value of g, and if the body is coming down, then we'll take it as a negative. And the third equation of motion, that is your position velocity relation, v square is equal to u square plus 2 plus or minus g h. Or first we'll write down the formula here. 2as, we'll write this as v square is equal to u square plus 2 plus or minus g into t. So here simply acceleration is changed with acceleration due to gravity g, and the displacement h we are writing in place of s. We can even write it as y, because we choose this y coordinate as the displacement. It is for falling of objects under gravity. So generally g will be most of the time negative. If the body goes up, we'll take positive. If the body comes down, then the value of g will be g is positive for going up, and g will take negative for coming down. So these are the equations of motion for a body when it is moving due to the effect of gravity, when it is going up or when it is coming down towards the earth. Now let us discuss about free fall. Motion of objects or object under free fall. Here you have to neglect air resistance an object released from the nearby surface of the earth, if the object comes down due to acceleration due to gravity of the earth, or we call this force of gravity towards the earth, and if we neglect the air resistance, then the object can be said to have free fall. The object is under free fall, we can say. Now in such a case, your acceleration, as we have discussed earlier, it will be taken as it's coming down. So coming down, then we take in a coordinate system, downside, this side. So it is negative g will take it. The acceleration will become minus g. And your the equations of motion, as you are releasing the object, here the initial velocity will be always 0. In such a case, the first equation of motion, v is equal to u plus or minus gt, will become v is equal to, this is 0, 0. Now coming down, so minus g, will take it here, minus g t. And in this case, we can write it as v is equal to minus g value is 9.8 meter per second square into t. So this will be your first equation of motion when a body is undergoing free fall. Now the second equation of motion will look like this: h, or first you write s, or let us take the equation h. The height is ut plus half of plus or minus gt. This will give you height h is equal to 0. Here also it will become minus half of minus g will take half of gt. So ultimately it will become h is equal to minus half of g value is 9.8 we are taking to t. Then it will become minus, we cancel it, 2 4s are 8, 2 9s are 18, minus 4.9 t. This will be your formula for displacement under free fall. And the third equation of motion, that is v square is equal to u square plus 2 plus or minus g h, will become v square is equal to u square is 0 plus into minus is the body is coming down, 2 times gh. This will give us v square is equal to 2 into 9.8 h. It will give us, this is minus, it will give us minus 19.6 h. The units will be meter square per second square, because it is v square. Both will have to square it. Height will be in meters and velocity will be in meter per second. So these are the equations of motion for a body under free fall. Now we can interpret these results in 3 ways. First one, I'm drawing here graphically, you can represent it. If this is your time axis in second, suppose this is the origin, 1 second, 2 second, 3 second, 4 second, 5 second, and this side is your value of g, acceleration due to gravity, negative value of g in meter per second square. This is negative of g, then minus 5, minus 10, then you know that the value of g is nearly equal to 10. This will show the variation of acceleration due to gravity with time. G value is minus 9.8 meter per second square. This graph shows variation of g with time. G value will not change, it will remain constant, it says. Then variation of velocity with time. T in seconds. This is the origin. 1 second, 2 second, 3 second, 4 second, and so on. This side if I represent velocity, meter per second, then minus 10, minus 20 meter per second, minus 30, minus 40, minus 50, minus 60 meter per second. Then the variation of velocity goes on increasing when it comes down. That's why you have acceleration, positive acceleration. So it is also an incline, straight line. They are directly proportional to each other. So this graph shows variation of velocity with time. And then you can even show variation of distance with time graphically. T in seconds, 0, 1 second, 2 second, 3 second, 4 second, 5 second, and decide distance in meters. In this case, minus 10 meter, minus 20 meter, minus 30 meter, minus 40 meter. If you plot it like this, the variation of distance with time will be inversely proportional. The graph will be of this nature. Like this you can represent. This is variation of distance with time. So like this you can represent it graphically. This will remain constant. Here g value remains constant. Here velocity and time, they are directly proportional to each other. But it all will come in the fourth quadrant here. Negative y-axis, positive x-axis. Time cannot be negative, positive x-axis. And then variation of distance with time. As time passes by, the distance will become shorter and shorter. They are inversely proportional to each other. So you get a curved line of this nature. Let us solve this question. The question says like this. A ball is thrown vertically upwards with a velocity of 20 meter per second from the top of a multi-story building, and the height of the point from where the ball is thrown is 25 meter. So this is your multi-story building. This is the ground. The height of the building is given as 25 meter. This is the height of the building. Let A be the height of the building. And then from the top of the building, from point A, a ball is thrown vertically upwards. Suppose let this point be C. And here, when the ball is being thrown from A to C, the velocity with which it is thrown is given 20 meter per second. So when you do the solution, you write down, this is for the first one, how high will the ball rise? Means you have to find out the height of AC, the distance AC. Now in this case, the initial velocity u is given as 20 meter per second. We know that the final velocity will be 0 because when the ball will be thrown up, the ball will come to rest at point C. So final velocity v is equal to 0. Then when the ball is thrown up, the acceleration due to gravity is going against gravity. So against gravity, the value of g will be minus, it's going up. So we'll take 10 meter per second square. It will be given here in the question. Take g is equal to 10 meter per second square, somewhat like this. Now, let the time taken for the ball to reach from A to C, let us take it as T1. We'll require this one for the next question to do. How long will it be before the ball hits the ground? So time taken from A to C, if it is T1. from C to B, if it is T2, then we can add it T1 plus T2. That will do at the end. So now first of all, the given information you will write down. After writing down the given information, you will see which equation you can use so that you can get this distance AC. You know here U, V, even acceleration you know, so you can use the third equation of motion. We know that V square minus or equal to U square plus 2GH. Let us take the height as H. This one, let us take the height as H. We are going to find out this one. Now, first of all, you have to think, well, throwing up, it is not under free fall, it's going up. So you will use your general equation. Here you write this plus. Then V value is 0. U, it is 20. So 20 square you will write plus 2. And G value is minus 10. H. So like this you can find out the height. 0 is equal to 400 minus 20h. So this will give you 20h is equal to 400. So h is equal to 400 divided by 20. So you get 20 meters. So this will be your first answer. So how high the ball will rise? Then the ball will rise by a height of 20 meters. Now from here you can find out how long it took for the ball to travel from A to C. If you use this equation, first equation of motion, V is equal to U plus GT, then you can find out the time, how long it took. Time will take it as T1 here. Final velocity is 0, initial velocity is 20, G value is minus 10, T1. So 10 T1 if you bring this side will be 20. Like this you can find out T1 is equal to 20 by 10 is 2 seconds. This way you can find out time taken by the ball to reach from A to C. T1 is equal to 2 seconds. That is from A to C in the upward direction. Now for the second case, when the ball will reach point C, then it will come down towards the earth. There will be a free fall. That will be the case of free fall. It will fall by itself due to the action of gravity. For the second case, how long will it be before the ball hits the ground? So what time it will take? Let us find out this time taken from C to B as T, T2. Let it be T2. So this one we are going to find out. This H2 you already know. H2 is equal to 25 plus H. That is 20 we found out. 25 plus 20 will be 45. So displacement relation, if you use second equation of motion, or we know that you can start like this. We know that displacement H2, let us take, is equal to UT2 will write for time taken to come from C to B, T2 plus half of GT2 square. So we'll put the values. H2 will be 20 plus 25 meter. U, now the earlier final velocity will become initial velocity. Now it will be 0 at the highest point. The velocity is 0 into T2 plus half of G value. As you come down towards the gravity, it is coming down, so we'll take it as positive 10. If it goes up, we take G value as negative. If it comes down, we take it as positive T2 square. Now this one will give us 45 equal to, this is 0, this is 5 T2 square, 5 T2 square. So T2 square is equal to 45 by 5 is 9. So T2 will be square root of 9, it will be 3 seconds. So T2 you will get it as 3 seconds. So for a ball to come from C to B, it will take 3 seconds. Now to go up, it took 2 seconds. Now to come down, it took 3 seconds. So the time taken The time taken by the ball to hit the ground will be T1 plus T2. So the time taken by the ball to hit the ground T, let us write T equal to T1 plus T2. It is 2 plus 3, both in seconds, so it will be 5 seconds. This will be your final answer. For the first one, you can write for the motion from A to C. Now you can write for the motion from C to B. This is for the motion from C to B. Like this you can write down. In the earlier case, you can write for the motion from A to C in the upward direction. Then we need for the downward direction. Now let us see Galileos law of odd numbers. This law, it states that the distances traveled by a freely falling body in equal intervals of time to one another as a ratio of odd numbers starting from unity. Unity means 1, that is the distances traveled by a freely falling body in equal time interval. They will be in the ratio of odd numbers, that is 1 is to 3 is to 5 is to 7 and so on. So we know that distance traveled by a body h is equal to minus half of gt square for a body falling freely under the action of gravity. This is our formula. So this displacement, if I take it as y, suppose as y, you can take it as h also, not a problem. Then if I draw a table here, suppose this is first one is time interval. If I take equal time interval, suppose first I am taking 0, starting from 0 when the body is being dropped, then t, then 2t, then 3t. Like that, if you go on increasing 1 t each, plus t will be 4t. Then distances h you can find out here. This time is indicating time interval t. H, it will be 0 if you put in place of t, then this whole value will become 0. The second value t, if I write capital T here, then it will become minus half of gt square. Then 2t, if I put it here, then it will become 4 times 2t whole square, 2 square will become 4 times half of gt square. Then if I take 3t, if I take here 3 square is 9, so it will become 9 times minus half of gt square. If I take 4t here, 4 square will become 16 times minus half of gt square. Like that it will go on. Now, if I write this h in terms of this value as h naught, if I put h in terms of h naught, I am taking this value as h naught, half of gt square. This one I am taking it as h naught. Then this will remain as 0. This will become h naught. This will become 4 times h naught. This will become 9 times h naught. This will become 16 times h naught. So these are the displacements that you will get it. Now if you take their ratio, in successive intervals, this will remain, this is a starting point, so no need to write any value here. Within these two successive t and t0, h naught minus 0, it will become here h naught. 4h naught minus h naught, like this you have to do h naught minus 0, it will give you h naught. 4h naught minus h naught, it will give you 3h naught. The successive interval 3t minus 2t will become t. 9h naught minus 4h naught, it will give you 5h naught. And 16 minus 9, 16h naught minus 9h naught, it will give you 7h naught. Let it go on. Now if you take the ratio of the distances traveled, ratio of the distances traveled, then you will get it here like this. In the first case, in the beginning, no distance will be traveled. The moment it's released, from here it will start. If you take the ratio 1:3, here you will get 1:3, 1:5, 1:7, 1:9, and so on. This is what it says, this Galileos law of odd numbers. That means what it says is, in 1 hour, if a body falls for 1 kilometer distance, then the next 1 hour it will fall 3 kilometer distance. Next 1 hour it will fall 5 kilometer distance, and so on. That means when the body is above, then the pull of the earth or the gravity is acting on it. The value of force of gravity is less. It comes slowly, but the moment it comes towards the earth, due to acceleration, due to gravity of the earth, the body becomes faster and faster. It comes down, and the distance traveled also becomes more and more. That is the reason why paradiving people, those who do free fall, they open their parachute when they are about to reach the surface of the earth. The moment they jump from a higher altitude, they don't require any parachute. They come down slowly, so no fear factor is there. They come down, but the moment when it is about to reach the ground, then the velocity becomes more and more. The distance traveled by them in certain interval of time becomes more and more. So they need to open their parachutes. And Galileo was the first person to study about the free fall of objects, and he gave this rule. They come down with the distances 1, 3 in the form of odd numbers 1:3, 5, 7. Their distance traveled becomes more and more as they reach near the surface of the earth. This way you can calculate and prove Galileo's law of odd numbers. Thank you and have a nice day.